Hello everyone. In this video we're going to talk about derivatives of inverse trigonometric functions. So here we have the inverse trigonometric functions. Remember this, if we have this -1, it looks like an exponent here, but this is part of the language. This means the inverse sign, right? This is not the reciprocal of sine, which would ordinarily be what the -1 in the exponent means. So this is the inverse sign. So the derivative of this inverse sign is 1 over the square root of 1 minus x squared. You can find these in the book. You should be able to derive these perhaps. The derivative of the inverse secant is 1 over the absolute value of x times the square root of x squared minus 1. The derivative of the inverse tangent is 1 over x squared plus 1. For the inverse cosine, it's very much like the inverse sine, but we have a -1 over the square root of 1 minus x squared, just has that negative sign. For the cosecant, again, like the secant, but we have a negative sign. 1 over the absolute value of x times the square root of x squared minus 1. And then for the cotangent, again, just the negative. So these are all the same, just with the negatives. Makes it a little easier to remember. Okay, so let's go ahead and apply these to some of these functions using these rules plus some of the other rules. So for the first problem, find the inverse cosine, the derivative of the inverse cosine of 3 of x. So we're going to use this up here. So I'm going to, it's the chain rule. So I'm going to first take the derivative of the inverse cosine. That's going to be -1 over the square root of 1 minus, now this has to be the argument of that cosine. It's the chain rule idea. And then I multiply it by the derivative of the inside, which is 3. So I can write that, a little bit different form, -3 over the square root of 1 minus 9x squared. And that would be the derivative. Okay, I have the inverse tangent of 2x squared. Again, I'm going to apply the chain rule. So the derivative of the inverse tangent would be 1 over x squared plus 1. This is the argument squared, so that would be the 2x squared plus 1. And then I multiply it by the derivative of the inside, which is 4x. Again, simplifying this down, I'll get 4x over 4x to the 4th plus 1. For this inverse secant, again, chain rule, we do 1 over the absolute value of 5x to the 6th times the square root of 5x to the 6th squared minus 1. And then I multiply by the derivative of the inside, which is 30x to the 5th. Okay, when I simplify this, notice that the absolute value of 5x to the 6th will always be positive because it's an even power. 5 will always be positive, and x to the 6th will always be positive. So I can eliminate the absolute value signs. And then I can take the 30x to the 5th divided by 5x to the 6th. That gives me a 6 over x times the square root of 25x to the 12th minus 1. And that's my answer. Okay, now let's do a more complicated chain rule where we have the sign of an inverse cosine of 4 of x. So again, following the chain rule, I'm going to take the derivative of the outermost function. This will be the cosine. I'm going to leave the inside part alone, the cosine of the inverse cosine of 4x. And then I'm going to multiply by the derivative of the inverse cosine, which is the -1 over the square root of 1 minus x squared. So I'll have a times a -1 over the square root of 1 minus, in this case, 4x squared. And then now I'll finally multiply by the derivative of the insidemost function, which gives me a 4. Okay, so we can kind of rearrange, put that together a little more nicely. The inverse now Here's a trick you can use. The cosine of the inverse cosine of 4x just gives me 4x, right? Because these will cancel each other out. And then I will have in the denominator 1 minus 16x squared, and I can simplify that a little bit more and make that negative 16x over the square root of 1 minus 16x squared. And that's my final answer. Okay, now let's go ahead and apply this to a slightly more complicated problem where we want to find the equation of the tangent line. It's a simple curve, the inverse sine of x, but we want to find the equation of the tangent line at the point where x equals square root of 2 over 2. So again, I'm going to just take the derivative. We'll use the y prime notation here. This is going to be 1 over the square root of 1 minus x squared. And then I need to evaluate this at the square root of 2 over 2. So 1 over the square root of 1 minus the square root of 2 over 2 squared. That's going to give me 2 over 4, 1/2. And 1 minus 1/2 is 1/2. So 1 over the square root of 1/2, which the square root of 2. Okay, so that's my slope. Now I need to find the point, right? So this is the slope, and I need the point so I can put it in point slope form. So the point, I'll get the y coordinate of the point by evaluating y at the square root of 2 over 2. So that's going to be the inverse sine of the square root of 2 over 2. Okay, and that's going to be pi over 4, because the sine of pi over 4 is square root 2 over 2. This gives me my point, root 2 over 2, comma pi over 4. My line in point slope form is y minus pi over 4 equals the square root of 2 times x minus the square root of 2 over 2. I can put this in slope-intercept form. All right, y equals the square root of 2 times x. The x is not under the square root. When I multiply the square root of 2 times the square root of 2 over 2, I get 2 over 2, which is just 1. And then I'll add pi over 4, so it's plus 1 plus pi over 4. I can't combine those terms, so I'll just leave it like that. The slope is square root 2, and the y-intercept is 1 plus pi over 4. And that's it.